Amit, you can start now. We are live.
Hi everybody, good evening and welcome to the webinar on Power of Digitization organized by CIO Klub and Siemens. I'm Amit Bhatia, Jacquard Group CIO. We are excited to take you along knowledge and fun-filled sessions for next 90 minutes. Let me introduce CIO Club for the members who are very new. CIO Club is the largest non-profit association of chief information officers in India. Our mission is to share and enhance knowledge on technological advancement and explore better business solutions for the IT community across the world. We will be having quiz sessions, so please download the Kahoot applications. 10 lucky CIO paid members will get vouchers. If you are not club member, please register now. I would request Ashish to play the AV now.
CIO Club is an initiative of CIO Association, an association of CIOs by CIOs and for CIOs. CIOs of Indian enterprises has formed the CIO Club, registered as the CIO Association. CIO Club is a non-profit and the largest association of chief information officers in India. It is registered under the Indian Societies Act. CIO Club was formed in 2008 and from one chapter in 2008. CIO Club has now chapters over the years. We now have chapters in Mumbai, Delhi, NCR, Chennai, Bangalore, Pune, Coimbatore, Hyderabad and Kolkata. From a humble beginning of 30 CIOs in Mumbai, it has now grown to more than 100 members across the country. CIO Club is governed by a governing body and chapter managing committees which drive the CIO Club objectives nationally. Our technology partners leverage this strong platform to showcase their products and services to the CIOs. The key objectives of the club are to share experience, enhance knowledge, and explore better business solutions by leveraging the collective wisdom of large number of CIOs who are registered members. The primary objective is to drive the business benefit to the organizations of the member CIOs and also help CIOs in their professional growth as effective leaders. The club also encourages entrepreneurial spirit by providing a platform for sharing and generating innovative ideas in the larger interest of the community. CIOs from every industrial domain indulge in this endeavor for the evolution of the IT community. Today, CIO Club is poised to scale up in terms of location spread, breadth of membership, and building new alliances to bring international best practices within the reach of the community. International club relationships are being built. One such initiative is CIO Net. Members of CIO Club gets free access to a wealth of knowledge and opportunities to network and mark their presence in the international community of CIOs. More emphasis is being laid on knowledge sharing, and also avenues of spreading this knowledge to other members of the IT departments are being set up. CIO Club is actively working with industry bodies such as NASSCOM, CII, ASSOCHAM to ensure that the CIO community has a voice in such forums. We have also constituted special interest groups on IT security and digital transformation to strengthen knowledge and experience sharing in these two critical areas of information technology. We are working towards a welfare program, an executive education program for CIOs, and it will be launched shortly for all the members of the CIO Club. So, join the CIO Club and start learning, sharing and caring. For more details, visit us on www.cioclub.com. Follow us on LinkedIn, Twitter, Facebook, Instagram and YouTube.
Welcome back. Let me introduce you to our very first speaker, Mr. Nitin Nair. He is General Manager, Digital Services, Siemens Limited. He will share his thoughts on how to leverage IoT 4.0 for optimizing business processes and transforming them to the new level, achieving efficiency levels in production, customer support and consulting in market, exploiting full potential of your plant. he will be sharing actual case studies with you all. So Nitin, over to you.
Thanks a lot, Amit, and a very warm welcome to all the CIOs joining this CIO Club session. Today, I will take you through the session, uh, staying ahead with Industry 4.0 together with my colleague Sushil Dubey. Sushil is our digital champion and has immense experience in staying ahead with Industry 4.0 because he has done several Industry 4.0 projects on his own. So he will also share the experience with you. And I'm Nitin Nair. I'm responsible for digital enterprise solutions and services for Siemens India. Um, so with this small introduction, I will request Sushil to share his screen and slides. I will take you through the first few slides and then hand over to Sushil to give you a deep dive into case studies. Sushil, we are not able to hear you. Have you unmuted yourself? So friends, I hope you are able to see the screen. Um, Stay ahead with Industry 4.0. That's the motto of the day today, how to unlock the potential of your manufacturing and staying ahead with Industry 4.0. Next slide. So with Industry 4.0, these are the normal challenges while starting the Industry 4.0 journey: what to do, where to start, when to start, how to realize, with whom. These are the challenges that we all see while starting the digital transformation. So if we would break these challenges into two major buckets, then it would be what and how. So let's look at the what and how, starting with the what. Yeah. So that's how normally things work. There is a digital vision of our management in every company to improve productivity, increase efficiency, uh, produce products with better quality at a lower cost, and have the flexibility to adapt to market changes, because today we live in a world with unprecedented market changes. Market changes happen very fast. Now, when we take this management's digital vision and try to translate it to manufacturing and make a digital roadmap, what does it mean? It basically means what is my percentage capacity utilization? Am I able to reach the design capacity? Yeah. What is my plant output? Can I increase the units per shift output? Can I increase the jobs per hour output? What is my line balancing? Is my production seamless? What is the kind of flexibility do I have? Am I able to manufacture variants on the same line? Am I able to schedule and reschedule my manufacturing based on the turbulences which are happening in the supply chain? Am I able to give on time delivery to my uh, customers? Can I get a higher first pass yield? How can I reduce variation in the of quality in my output? How can I do a digital quality validation? So these are all the manufacturing challenges while making the digital roadmap. Going forward, so basically, as you see, it is about tying the business and the technology together. So that's the what. Going forward, yeah, going forward, how do you do it? So Basically, starting with a focus on the business goals, as I spoke about, increasing the line output, what is my overall production effectiveness, what is the track and trace, am I able to schedule and reschedule my production based on the turbulences and changes in the incoming orders, what is my CPCPK, how can I improve my first pass quality, what is the rejection and rework cost that I am having. So it is always good to start with these KPIs because then we can set a baseline and measure the output of and the impact that the Industry 4.0 transformation has had on the manufacturing. Moving ahead, let's look at how to do this. Yeah, how to make a digital roadmap based on an in-depth immersion and key insights. So as you see, it's a small journey, or rather a journey, starting with a leadership vision workshop, then making a deep dive into the manufacturing value stream, having a co-creation workshop with all the stakeholders involved. So it's not about only the manufacturing IT, but also about having all the other manufacturing stakeholders in the workshop, because what we have seen from our experience of these workshops and these digital maturity assessments, that most of the challenges actually lie in the interfaces between the various teams and the various departments. And this digital maturity assessment and workshop is then followed by the building of various scenarios. And after we have built the various scenarios, it is about measuring how these scenarios will impact and what will be the cost of implementation of each of these scenarios. So it's an effort or investment versus impact, with which you can then prioritize which are the scenarios which you would like to implement first, and then do the final program design. So that final program design brings you there. Yeah, this is important. This is a very important slide, because the complete Industry 4.0 transformation is always based on the ability to get data from the shop floor. And that we have found is always the biggest challenge. Now here, how do you define the data scope? First of all, what I will do is I will take you to the picture on the right hand side, showing major reasons for losses in manufacturing. So if you see, normally when we do a workshop, our people in manufacturing already know the major losses and or the major reasons for losses in manufacturing. They have a fair idea of what are the points which are stopping them from unlocking the complete potential of manufacturing. And the traditional approach is to always focus on the top three or the top five, which are shown on the right hand side in the picture. But believe me, the biggest challenge is in the others, which are shown in the left side in a gray arc, because these are the ones which are unidentified challenges and have been stopping from reaching the full potential, but are never identified. And today, with all the digital technologies, we have the opportunity to unravel the others, unravel the topics which probably are also not known fully to the teams working on the shop floor, and bring them out. And here you see an example of defining the data scope by bringing production, manufacturing engineering, quality, maintenance, and logistics teams together, and then asking them and doing a joint deep dive into each of the topics from production, manufacturing engineering, quality, maintenance, and logistics. Because for a seamless manufacturing and for unlocking the complete potential, all these teams and departments have to work in complete synchronism so that we are able to reach a completely new level of productivity. So, looking further at the data scope, the next challenge that we have commonly seen and is you define and then you find that the shop floor is a few years old. It is 40 years old shop floor or 60 years old shop floor. There are machines which are there on the shop floor. There are lines on the there which are there on the shop floor, and we need to get data from these existing lines and existing machines. How do you do that? There are several challenges. First of all, there are sensors missing on the shop floor from where you can get that. Secondly, there is a missing acquisition network from where you can get the data. After you create the data lake, only then you can do things like MES, like asset performance analytics, quality, energy. So all of these will finally depend on the quality of data which comes from the shop floor. And therefore, we say that when you are looking at an Industry 4.0 transformation, you should look at all the work packages. And these are the work packages which you see on the right hand side, like networking, like IT infrastructure, networking, cybersecurity, sensors, asset integration. So from here, I would like to hand over to Sushil Dubey, who will take you through case studies showing you how this data lake was created and how the benefits were created in our own Siemens Kalwa factory, which is a digital factory. So over to Sushil. Sushil?
Sushil, you are on mute still.
Sushil, you seem to be on mute. Please unmute yourself. Hello, Sushil, I'm not able to hear you. Siddharth, are you able to hear Sushil?
No, no.
Okay, so looks like we have our first connectivity challenge with Sushil. No, Sushil, we are not.
Sushil, you can just leave your controls. Let me manage it for you. Give me 1 second. Sushil, now unmute yourself from there. I'm sending you a request. Now, please speak. No, audio has a problem.
Maybe Ashish, you can ask him to remove the headphones. Maybe there is a problem in that device also.
Yeah.
So directly he can talk. Remove this. Sushil, you can remove the earphones. Directly you can talk.
Am I audible now?
Yeah,
Yes.
now you are audible.
Yeah, you are audible now.
Perfect.
First challenge, and now let's move ahead.
So we are talking of integration of devices.
Yeah.
So please.
Yes. And this is also
Sushil,
exactly what
Sushil,
happens if you don't correctly select the sensors on the shop. So I hope my screen is visible or not.
Yes, Sushil, you can start.
Yes, Sushil, your
Yes,
screen
my
is
screen is
visible. You're audible. Please go ahead.
Okay, thanks. So, Nitin, thanks for the brief introduction. And with this background, I will take you through a few case studies, few success stories which we have ourselves implemented, and we have been a important partner in driving the digital transformation. So the first success story comes from our own Siemens's factory based out of Kalwa. This is a 45 plus year old switchgear factory. And just before we get into the story, a brief preambles, how we did digitalization, but importantly, what was the need behind you doing this digitalization. So basically, this factory, as I mentioned, is roughly 45, 47-year old. We were producing older generation products, and the latest generation products were being imported from our parent factory in Germany and supplied to the local market. But then after importing, meeting the local price expectation was the biggest challenge. And therefore, we thought that we should start producing locally. But when we talk of producing global products locally, there are many things, including quality, which comes to us as a challenge. And to be precise, these are the four challenges that we had initially when we really decided, yes, we want to start producing these products locally now. So when it comes to speed as the challenge, the biggest challenge was time to market, or how quickly we can start producing these global products in a locally developed or designed process, at the same time meeting the global quality standards. So for us, basically quality was the biggest challenge. Reason, if I talk of a global product and if I compare this with an old generation product, roughly 3 times more parameter check is what was required in this new generation product. So what you can see already here is 68 parameters compared to 22, number one. Number two, because of the construction of the product itself, the checking of some of the parameters was a big challenge here in terms of technology. And when it comes to flexibility, see, the process that we have in our parent factory, it was not feasible to adopt the same process or copy the same process in India for various reasons, like I would say initial investment or capacity there and capacity here, rather demand there and demand here. Most importantly, we thought we should have a make in India or I would say process. And this was when we created our own design of process. And today, when we talk of flexibility, we can produce a batch of one product. So essentially, we don't have to wait for, let's say, order of 100 products or 1,000 products as an MOQ, what we typically call. Here, the batch size of production could be one. However, the cost of production will still remain whether it's one product or 100 product or 1,000 product, irrespective of that. And more importantly, it's flat 9 seconds after which each product comes out. So that's the efficiency, I would say, that we are operating at today. So how we really did this transformation is something like this. Basically, we adopted the digital twin based story, wherein we first created the digital twin of the product. We created a virtual product, and then the actual product was realized. Most importantly, when we talk of process, this is where the digital twin of production comes in picture. So this is where we created a digital twin of production process. And then here we could, try what's if, lots of what if scenarios. We could simulate various conditions. Most importantly, since it was a brownfield conversion, the factory's layout and construction wise, infrastructure wise, it was a constraint to us. So this is something where we also could simulate that how the layout could be, and what could be the best material flow, for example. Yeah. And then once we were clear with the production process, we really implemented the process. And while implementing, we ensured that each and every data point gets captured. We maintain traceability for each product. We capture the performance of the machines, of the equipments, of the assets. And when in the process, when we started capturing the data, we really started getting lots of dashboards, and this is precisely what we call it as digital twin of performance. So this digital twin of performance really gives us lots of insights from two aspects. One is from a day-to-day production or operations perspective, that okay, how the production planning could be, are there any challenges with respect to the shop floor from material perspective or breakdown perspective, so from a day-to-day operations perspective. And second is, how could I reduce my cycle time, how could I exploit my bottlenecks, how could I really change the product design, and in turn, how can my process be adapted? So this is again from a little bit long-term perspective. But both put together, this is how really speaking digitalization helps us in lots of bringing lots of efficiencies in terms of white collar, in terms of let's say blue collar as well. And going a little bit deeper into the process, if you see, first thing is variant management. The biggest benefit that we this factory get today is, here we are talking about 200 odd variants which are produced in the process. However, the flexibility that I was talking today is, uh, theoretically speaking, the first variant can be of batch size 10, and the second variant can be of batch size 1, then the third variant could be of batch size 3, and all of them being produced back to back without any manual intervention, without any changeovers. So it's basically a typical man to machine, machine to product, and product to man communication, and wherein I would say there is also something on quality perspective. The quality, some of the processes are set in such a way that depending upon the input material, depending upon the incoming quality, the processes adapt themselves. Yeah, so I would say there are some intelligent machines as well, which take care of the variation in the raw material and ensure that whatever quality is delivered is in let's say in the range of acceptable norms. So invariably, I would say, irrespective of what variant we are producing, we absolutely have the flexibility to change the routing or adapt the routing. The quality wise, as I mentioned, machines are quite intelligent. And more importantly, it's absolutely supervised digitally. So in case, let's say, the once the shift is loaded, and let's say after, let's say, 3 hours, if the supervisor realizes that I need to change my plan because of some material problem, it is the system that guides the supervisor and the shop floor people that given the scenario, this is the best you could adapt now. So that's the level of digitalization, and that's the level of efficiency we have really received. And not only that, coming from a transparency point of view, we have also gone to an extent of creating lots of transparency from utilities perspective. Utility includes our solar power generation plant. We have a captive solar power generation of 2.3 megawatt. So, forecasting the demand, then from a compressed air perspective. So, managing all the utilities is also taken care. And this is again, when I say digitalization, a very, very important aspect of creating transparency and going one step ahead, creating analytics, and the system guiding me that given these scenarios, what am I consuming more energy to produce a particular single product, or what is the benchmark level. So that's the kind of insights and the decision making capabilities we have got from the system. So to sum up about the success story, um, this is what we have achieved. We could produce 77. We used to produce 77 variants in 3 lines. However, by doing digitalization, we can now produce 180 or close to 200 variants in one line, and that too in 9 seconds flat. Yeah? And from a quality perspective, as I mentioned, it's a global product. 68 parameters are checked as compared to 22. And if you see the cycle time, again, it's 9 seconds as compared to 60 seconds. So that's the major, I would say, point where we get productivity. And the most important aspect, it's a local process, but we produce products for local and global market. So the point is, if we see two products, one is made in Germany or made in Europe, and one is made in India, we have absolutely no difference in the product, including the certification, approbation, everything. The only difference on these products would be text, which is made in India and made in Europe, and that's something we are really proud of. So with this, I will now move on to the next case study. I would request all the audience to park your questions, or let's say type your questions in the chat box so that we can take these questions later on. So I am now moving to our another success story, which was for a manufacturing setup, which is again, I would say, a 50-plus-year-old plant. Here the challenge was when they thought of starting their transformation journey. The biggest challenge was absolutely no idea about how much material is lying on shop floor, how much material is there in my warehouse, when the material is being issued, what against what requisition, but more importantly, when we talk of a product, which product is being assembled. Sometimes it's a made to stock, sometimes it's a made to order kind of product. It's a mixed scenario. So which customer's order is in progress? When it comes to a product traceability, what is the history of this product? From a process parameter, let's say if I have a tightening torque as a critical characteristic, am I achieving the required torque and am I able to log the data? Yeah. So these were the topics that were really speaking, bothering from a day in day out perspective from an operational point of view. And this transformation, what we could do is, first of all, integrate the entire assembly process, create a backbone, number one. Number two, if you can see, what we could do is tracking and tracing as and when the assembly is happening. So the product is kept on the trolley, and the trolley contains an RFID tag. However, each product contains a unique barcode. So this barcode contains some product code as well as serial number. So whenever the assembly happens on the shop floor, there is also a mistake proofing or a validation which happens on the shop floor. At the same time, I am also validating the bill of process, which means as per the product, I am also following the process and ensuring complete flexibility in terms of processes. So now in order to do this, what we also had to do was a backward integration to their warehouse management. So then we went one step back in terms of process, and we really integrated their warehouse as well. And if I were to talk about the complete unified story today, how the process looks like is, first of all, whenever a production order is created in their ERP system, immediately one requisition goes to their warehouse, a pick list gets generated, the entire kit gets formed, and the kit gets delivered on the shop floor. When it is in transit or on the shop floor, the kit can also be located by the virtue of RFID tag. And when the kit moves or when the assembly happens, then the traceability of the product is maintained. Now, this traceability includes again two aspects. One is from the process point of view, and second is more importantly from a quality perspective. So, all in all, I would say right from receipt of material, management of warehouse, till assembly of product, maintaining complete genealogy of the product, including quality perspective, operators details, which operator has done what operation, at what point of time. All these, this data is also a part of the genealogy, and this is precisely now what we are able to maintain. And by doing this, believe me, when they were driving their internal kaizens, uh, they could reduce more than 50 to 60% of their searching time, what they typically used to do when they used to retrieve the material from the warehouse. Number one. Number two, in case of customer recalls, or whenever a product is ready for shipping, but before shipping they notice there is some deviation in quality. Within no time they can figure out what is the history and where it has really failed. So this basically brought lots of white collar productivity and also the turnaround time, I would say, when it comes to their quality processes. So that's about the the second success story from a real traceability and warehouse management, material management, inventory management point of view. Yes, inventory. I didn't speak about inventory, but they could also save upon lots of inventory carrying cost, and the inventory number of inventory turns were also increased, which was one of their KPIs. So this KPI was always red. However, they have now started looking this KPI into yellow or towards green. Yeah, so that's again a tangible benefit, I would say, they have started receiving. So request again, you can park your questions as far as this success story is concerned. I now move on to my next success story, which is again transforming a manufacturing setup, which was roughly 65-year-old plant, quite a heterogeneous mix of machines, assets, heterogeneous not only in terms of OEMs, but also in terms of make, in terms of the version of these machines. So even if I say one OEM, let's say 3 generations of machines are there on the shop floor. And this was the biggest challenge when we started, drilling down into the process, starting to create the architecture. And when we were, doing the complete shop study, see 152 odd machines was the scope, out of which again 35 plus machines were standalone without, they didn't have even the capability to connect. However, that was the first thing that we did, installing some sensors, some connectivity layer, and doing the southbound connectivity. So with this, again, a OT network, typically what we call a plant level network, was a completely redesigned. Now, typically what happens is when we talk of a plant level integration and a network integration, this topic is something which was never thought of, and therefore if we see the networks on the shop floor, it has always been an organic growth. They were never really structured, and this also increases the risk from a cyber attack perspective or a cyber security perspective. So this is also one of the topics that we let's say touch base. So designing, let's say, the network from various angles, like let's say redundancy, then the ring type of architecture, what we called in terms of network, that was also taken care, and which ultimately resulted into this kind. So if we look at the complete solution landscape, see, this is how the entire solution looked like. Uh, I would say machines or cells were again heterogeneous, as I mentioned earlier. However, first layer was the interfacing layer to establish the data connectivity. And then we moved one step ahead, that was line performance layer, again locally for the respective cells, respective machine units, or let's say small plants. And then going at a bigger level, it was at the MES layer where the data aggregation was happening. And again, lots of, let's say, decisions from a shop floor were being taken. And we go again one step ahead, or at an enterprise-wide level, wherein the manufacturing intelligence as a topic comes in picture. So this is where, topics like benchmarking from one machine to another machine. Let's say, what is the energy consumed per product produced on first day of the month and third day of the month and 15th day of the month. These are the topics which can really be, answers to these questions can be, let's say, derived from this manufacturing intelligence as the module. So going one step ahead, see, in some of the cases, there are also topics when I talk of manufacturing intelligence and analytics. We are also talking about sometimes, let's say, artificial intelligence based algorithms or machine learning algorithms which are deployed on the shop floor. And this case study also talks somewhat about, though it's for the same plant and one more for the other plant. The example what I'm trying to explain here is, in case of, let's say, some of the solutions which require lots of data crunching capacity. In this case, what we have done is we have made it quite modular and quite simpler in nature, wherein first of all establishing connectivity from a shop floor perspective is something like this. Sorry. Yeah. So first thing is fetching data, acquiring data, which is what we again call as a southbound connectivity. Using the edge devices as a device to do some data crunching before we even send to the cloud or the I would say data warehouse. And this is where again we have deployed our algorithms. So when let's say we want to have some prediction in terms of process, what we do is this system gives us, let's say, predictions that okay, given these set of parameters and given this set of your input variables from a process point of view and material point of view, for the next 2 hours, this is the quality level you are going likely to get. Not only that, going one step ahead and prescribing that yes, now that given these predictions, if you want to have let's say the uh, quality in a certain range, probably these are the parameters what you could tweak, and then you will get the quality in the required range. So to make it more simpler, how I would put it this way: data acquisition portion, edge device is where we deploy those algorithms, and then rest remains still like a black box, which we, let's say, deploy the algorithms, and these algorithms also gets enriched. But as a user, they really don't have to get into these things that okay, how user friendly or how much easily deployable this is. This is something we have a good capability in. Yeah. At the same time, when we talk of deploying, there is something called as Edge Hub, which takes care of these deployment and the transfer of data. And then as a user, what we also do is, let's say there can be escalations, there can be alerts, triggers. So it happens through emails or SMS. Yeah. So this is on the right side, what you see is for a discrete process. On the left side, what you see is for somewhat a continuous process. So the concept still remains the same. So data acquisition, now here on the right side, there are some machine level parameters. So basically this case study was for predicting the failure of the tools, let's say a drill bit. And our algorithm could predict that after these many hours, the drill bit is likely to fail. And therefore, the organization could save their downtime. So this is something what we could deliver by doing this application. So that was from a, I would say, edge device and edge application perspective, how these things could be really simplified and deployed, and still the, let's say, I would say high level expectations like prediction of quality, prediction of downtime, all these things could be predicted. Yeah? So really speaking, bringing in efficiency in terms of uptime of my plant. That's what the topic is. So
Thanks a lot,
that was
Sushil.
yes.
Thanks a
So
lot,
I
Sushil.
am
So from
yes, please, Nitin.
so I think from the process and the manufacturing, we will now move to the power and the utilities, because uh, secure power is also very important. Amit?
Yeah. So Nitin, if you have any comments, we can, or I can stop sharing my screen and Amit can take over.
Yes, Amit. So we'll move. We cannot hear you.
Amit?
Is it okay now?
Yes.
Sorry. Yeah. So to keep the learning journey on, now I would like to introduce Mr. Dinesh Pawar, Head Power Technologies, International Siemens. He will be sharing his intellect on power quality analysis of machines, which is CA guidelines, predictive and preventive analysis to avoid power failures, various AI techniques offered by Siemens solution. So over to now, Mr. Dinesh.
So, thanks, Amit. My screen is visible. Just as some confirmation.
Yeah, your screen is visible, Dinesh.
Okay. So, thanks for giving this opportunity to present on this topic to the CIO Club. So, as introduced, I'm Dinesh Pawar. I'm heading the Power System Consultant Group within House of Siemens. And I welcome you all for this power quality analytic presentation. So before going into the details of power quality analytics, I would like to brief about what we do within House of Siemens, my group, what we are doing. So we are a team of consultants within Siemens and providing our expert solutions or services for energy systems and digitization. Our group is founded in 1956, and we have more than 30 offices all across globe. With 250 dedicated power system consultant working on providing solutions to more than 2,000 customers by doing at least 1,000 projects only on power system for supporting them on their journey for energy system solutions and digitization. And these solutions we serve all across verticals, so all sectors we are serving. And to serve this, we have arranged our group into 3 segments basically. The power system consulting group majorly deals with grid design, planning, optimization, and operation related aspects of power system. Then we have an energy business advisory group, which takes care of infrastructure strategies, business advisories related to regulatory services, transformation services, and it takes care of all commercial and economical aspects of the power system in energy business advisory. Then we have a software solution group, so we have best-in-class software solution tools which we use for all these consulting projects, and also we help our customer with this tool so that if they want to do the studies on their own, they can do this by using this tool. So with this, all 3 segments, we form a vendor neutral a subject matter expert organization, and we become a trusted advisor for our customers. So today the topic of a discussion is power quality analytics, and here I would like to talk about this digitization services, what we all and what benefit customer can get out of these digitization services. So before going into this, what is power quality? Basically, power quality is nothing but a voltage quality, which is derived through the curve, the voltage curve, the shape of voltage curve, what you are getting at a point of coupling. So that shape of curve defines the power quality, and this shape of curve have impact because of various systems in your system. So at the right hand side, you see all the different problems in the power system, and because of which this power quality curve get distorted, and that is what we call as power quality issues. So these issues includes like flicker in your system. These issues like it includes like ripple in your system. So in your power system, we have a lot of disturbances and transients in our system. So that also impact this power quality curve. And because of this distorted curve, we have seen through all the experience that we are facing a lot of challenges and power quality issues, which result into various aspects. Some of them are flash on the right hand side, like overheating of your equipments, accelerated aging of your equipments, then vibration of motors in your system. Then we have disturbances of drive in your system. So various impact this power quality can have on your system and on your equipment. And however, this power quality traditionally has been a gray area for the operators, and it has more often, been studied or been explored. Where once we face problem, once we start facing problem like overheating, like failures of your drives. So such kind of issue when we start facing, then we explore this area, or else we explore this area because of some regulations by the energy providing agency or the distributing agency. So these unattended power quality issues, can land up into major equipment failures, and this is what I will flash on my next slides, that what impact it can have on your equipment and your system if it is not attended. However, with new development in digitization and data science technique, there is, we have a solution which will enable us to beforehand understand this power quality parameters and try to mitigate it so that we avoid these failures or these damages to our system. And this is what the topic we wanted to address here. Before going into that, just wanted to show some images based on our past experience. Like these are very small damages, but the impact what they cause is quite huge sometimes. So, like in one of the case, because of some small capacitor, less than €10, there was an outage of an entire plant because this capacitor failure resulted into high frequency distortion at the burst voltage, which ultimately resulted into outages of sensitive drives and ultimately resulted into outage of entire plant. Yeah, because of cascading tripping. In one of the case, there was a fault at one control panel, which again resulted into high frequency distortion at the bus, and we have seen entire air conditioning system and drives was got outage. Then in one of the example we have seen multiple outages and damages because of transient event. Because transient event ultimately resulted into outages of some switch gears, and it has multiple cascading effects. So impact, like these are the very small events, but the impact what this event can have is quite big. These small disturbances or small failures are happening because of power quality, but we'll analyze it only when we'll study the system, only when we'll have the data of that system available with us. Then only we'll be able to study at what has gone wrong for tripping of such kind of failures of such kind of small equipments or maybe product, or what has happened actually. So for that you need to have details of your system, and that is what we will provide in our solution. So knowing the impact in India, CA also have framed some guideline. So as per the technical standard for connectivity to grid 2019, CA has given some recommendations for power quality measurement. Important measurement like power quality, harmonic is also one of the important aspect of it. And this harmonic is in generated by various harmonic sources. So CA has recommended that the limit has guided the limit of current injection, the harmonic in current by bulk consumer should be continuously measured and at the point of coupling, and it should be as per IEEE 519. So there is some guideline of harmonics in your system, and you have to follow that guideline. Additionally, CA has also recommended to share and record the power quality parameters for the bulk consumer. So that recording has to be given to the distribution licensee. So bulk consumer are supposed to record the power quality parameter, which is voltage, sag, swell, transients, and harmonics. Yeah. So these are parameters which are required to be measured and given to the distribution licenses by bulk power consumers. This is the guideline. Then one of the suggestion what CA has is power quality measurement or maybe the harmonic is not a one-time activity or maybe once in a year activity. It should be a continuous process. So traditionally, what we are doing is we measure harmonic through a handheld meter, and we analyze that data, and then we give some mitigation, and then it's done. But CA recommend that harmonic measurement should be a continuous process, because the harmonic load, the loading condition of your plant will change depend on your production. So harmonic content will also depend on your loads. So that's the reason it is recommended to have it measured continuously. So apart from harmonic, voltage sag, spell, flicker, and disturbances, the transients shall be done as per IEC, shall be measured as per IEC, and this measurement has to be given to the distributor licensing. So some of these guidelines have been issued by CA so that we avoid these damages to your system, and ultimately these damages which is resulting into the cost to you. So where ideal power quality should be applicable for each and every customer and consumer. However, it becomes more crucial to the consumer where we have a process critical production. So continuous process in one equipment can result into entire process failure. So there, such kind of measurement is very critical. Again, such kind of measurement is critical where you have seen outages, but you are not aware why these outages are happening. What is the reason behind it? So if you are facing such kind of outages, then you should go for a continuous power quality measurement. Then if you are having frequent failures in your system, so that failures needs to be investigated, and there you need a continuous power quality measurement. Also, IT infrastructure like, for example, data centers. So they are quite sensitive to the power quality. So data centers should also have a continuous power quality measurement. So ideally, power quality is required, measurement is required for each and every customer, industrial customer. However, these are some of the examples which clearly highlights the need of doing this continuous measurement, so as to avoid the impact of bad power quality on your equipment. To address this, we have Siemens as a solution, what we call power quality analytics. And this is what I'm reflecting on my slide. So what we do in this analytics is, first of all, we will install the power quality meters. So SICAM Q200 is a power quality measurement meter, which measures all these power quality parameters, voltage, sag, swell, disturbance, and harmonics. So it measures and record this for some maybe 15 days to 30 days, depending on sampling frequency. So which can be 3 seconds to maybe 6 minutes. So it stores that data. So we install that power quality meters at various feeders. Most importantly, at point of coupling, the feeders in feed from where you are getting utility supply. So there, the meter has to be installed minimum, and then we recommend with the client we understand which are the critical feeders, and there also this meter installation can be taken place. And once this meter is installed, there is a communication. So data has to come out from the meter. So there are various ways. Manual way is also possible, but as we are talking about digitization, it has to be a digitized way, and that we do through a VPN channel. There is a possibility of giving this data on the cloud. So we have Siemens Cloud, and there also we can push this data. But also, depending on the customer's interest, we can adopt the VPN connectivity also, and this data can be shared to a central server through a VPN connectivity. Third important step consists is accessing this data. So through our various Siemens server, we access that data. So that access could be a continuous access or maybe a periodical access. So at the start, whenever we start any project, we try to do it continuously and try to see how is the data and what is the quality of data and try to analyze that data. However, depending on the situation, we can have that frequency changed. And then once we get this data, the actual work start. The PTI consultant work start here, where we process that data and we try to understand the signal. We trying to process that signal, and then various processes are there, which is I will explain again more in detail in the next slide. So that signal is processed, and then based on this signal processing and analysis of the data, we find out the weak point in the system, and then accordingly provide the recommendation, the mitigation based on the abnormalities what we find in the system. So in short, this is the process description, which from collecting data, which gives us insight what is happening in your system. And then this is the analysis aspect, because having a bulk data, you have to analyze that data and then find out what is important in that data and which can cause future damages to your system. So once we have this, the details of this process is like, we have this data and then we do clustering.
Sorry, Dinesh, I have a quick announcement that we will be shortly having a quiz after this knowledgeable session. So kindly download your Kahoot application or log into kahoot.it, right? You can see the message also on your screens, right? So just be ready. Thanks, Dinesh. You can continue.
Yeah. So this, clustering, after clustering, we go into the details, like we find out aggregated values and what is going on into the system. Some of the transients, we analyze, and you can see on the example, like here we have seen some transient, and we analyze that transient and try to find out what was it, and then we find it out that it is a transformer switching on condition. Similarly, there was one transient which was because of motor switching. So this was a normal operating condition in your system. So this is done by a software and with our consultant, and then software with artificial intelligence and machine learning, the software learns that if such kind of transients is there in the system, it is a normal operation. So software is learning by itself. So that next data set, if similar situation comes, it will not show me this situation. It will consider this as a normal operation. So this is the beauty of the artificial intelligence and machine learning. Similarly, there was some switching. So again, this happened on some date, and again it was repeated. So this will not flash to our system. So it will not show me this data, and I will not invest my time into go into the details of it to find out what was the issue. So however, the abnormal situation like one is here on 14th of March. So here we find that there is some abnormality which is not same as what we have seen earlier. So we go into the details of this, and then we find out that why it has happened and come to a conclusion that it was because of high impedance fault. And then it needed immediate attention. So immediately we inform it to the client that, okay, you need to look into the aspect. There is something, some fault is there, which is high impedance, which is not tripping your system, but it is, distorting your power quality. So such kind of analysis is, done, and then these are the some of the example of analysis and our findings. I will not go into the details. Maybe I can keep it for maybe 5 seconds on the screen. So the message or the slide what it depicts is what are the different quality parameters. So as I mentioned, the transient, voltage, sag and swell, harmonics, phase imbalance. So these are the parameters, and what are the causes why it happens? There are various reasons. Some of the reasons which we come out of our experience is listed here, and what impact in long duration, or maybe sometimes it will have immediate impact, and sometimes it will have a long duration impact. Like for example, transient, it will not have a dielectric failure immediately. It may take some time. So such kind of impact it will have. So these are the power quality parameters which are having impacts on your system, not immediately but in long run. And this power quality analysis services gives insight into this impact and will help you to prevent this impact beforehand. So this is the service what we are providing, and the benefit what customer is getting is clearly they can prevent their production loss because of the impending impact, impending damages because of the power quality issues. It will, they will be able to identify the disturbance source that where from it is generating, and then isolate that source. And in root cause of analysis, why it has happened needs data, and we do disturbance investigation also. And data has remained a challenge whenever we are doing disturbance investigation. So once we have a continuous measurement, we'll have this data, and that will help me to find a root cause of any disturbance which I'm facing in my system. So ultimately, all these steps will ensure the maximum availability of your supply, and ultimately will reduce the downtime, and which will ultimately result into a cost saving. So power quality analytics helps you to predict the expected failure. It reduces breakdown. It help you to benchmark your performance, your equipment performance with the desired performance, and in a sense, it will give you a peace of mind. So this is the service details. Maybe I can.
Dinesh, yeah, we can just have our first quiz. Yeah.
So should I? Okay.
Yeah, we can cover project examples after the quiz. You can carry
Okay.
on with that.
Yeah.
Over to you, Amit.
So maybe otherwise, maybe if you can give me 2-3 minutes more, I can.
No problem. We can have it after the quiz. That's
Okay.
fine.
Okay. Okay.
You can carry on. Yeah. Yes, Amit.
Hello. Yeah. So thanks, Dinesh, for your valuable inputs. So we have for you now a short quiz so that knowledge sessions become more interactive and fun-filled. We have Amazon vouchers for the winners. So please do not go away. Please be ready with your Kahoot applications. You can use kahoot.it to start applications. Please enter PIN number and then enter your mobile number when it asks for the name. So top 5 winners will get gift vouchers, right? And yes, that is not the end. We have another quiz after the last session, which we are planning for on security. So over to the support team for quiz. We can start the quiz now. Great. So you can see the PIN number 702259. The PIN number is 702259. Guys, you have to register with your mobile number. You can use your native applications, or you can go to www.kahoot.it. Right. So we have the attendees. Very good. So waiting for a few seconds before we start. 702259. This is the PIN number. So we'll wait for some more guys to join in.
Amit, just noticing on the screen, some people have not logged in with their mobile numbers.
Yeah, I am also noting that. I hope those we will not be able to identify those guys. So please mention the mobile number. If you are the lucky winner, then you have to mention the mobile number. Some of the guys we know, Sunil Gurwani ji. So maybe he has not mentioned the number. So yes, quick on. I think yes, we are there. 50% guys still remaining. Yes, you have to be quick. 702259. Shyam, Alok, RG, Selvaraj, you have not mentioned the mobile number. Yeah, we are starting with the quiz. Here is a question in front of you. Which of the following power quality issues could cause damage to electrical equipment? Options are voltage imbalance, switching over voltage, harmonic resonance, or all of the above. I'm repeating the question for you. Which of the following power quality issues can cause damage to electric equipment? Yes. So 31 guys are correct and 6 are not able to make it. Great, great. I think guys have tried, and Upkar is winning with 835. Second question, which of the following does not come explicitly under power quality monitoring? Voltage and current harmonics, voltage swell, vibration in motors, transient over voltage. Great. So answer is vibration in motors. 31 guys have correct answers. Now Mr. BP is leading. Upkar going down from first to third. Yes, we have to try next question. Which of the following conditions in the system does not poses a danger to plant equipment? Heating of equipment because of harmonic current, steady state over voltage, ferro resonance condition, none of the above. Yes, 5 seconds. Very good. 22 correct answers. Now car has again gained the lead. BP number 2. The next question, penultimate question. What methods are applied on continuously measured power quality data to efficiently predict impending failures? Machine learning to detect abnormal states, data science to derive statistical states, both A and B above, manually analyzing voluminous power systems. 44, both A and B above. Upkar leading the BP second. Well tried. Alok, you are fourth. Fifth question. Which of the following power quality parameters must be monitored continuously in order to avoid consequential production? Okay. So you can see the 4 options. $39. Yeah, great. 3670, 5 out of 5. So I cannot see the name. BP is second. And who is the first? Upkar. Oh, great. So congratulations to all the 3 winners. So our team will contact you. I think mobile numbers are clearly visible. So this is the analysis, I think. Great. Upkar, congratulations to you. BP, and the third is the number. So I think I should congratulate all 3 guys. So winners will get the Amazon voucher soon.
Yeah, Amitji.
So I would, yeah. So I'm just waiting for Akash to.
I
Hello.
think
I'm there,
he's
so if
not the
I
presenter.
have to
Yes.
start, yeah.
Okay. No, not. Yeah. So I think we are over with the fun-filled quiz. Now I would request our third speaker, who is uh, uh, basically Mr. Akash Apurva. We talked about efficiency, accuracy, resilience. Very important factor to achieve this is cybersecurity, which actually complements to bridge gaps in any solution built for digitizing IT and OT. So we have with us Akash Apurva, Practice Head Digital Enterprise Services, Siemens Limited. So he will take us through various architecture and solutions of industrial security. He will also tell us about
Amit,
accessing
I
security. Yeah.
Amit, hi, this is Beryl. Just before that, I think we wanted to conclude with the use cases. So can we just take 5 minutes where Dinesh left off and conclude the use cases and then get into this, if that's okay?
Okay. So we are
Thank you.
actually having specific time. So please complete it very quickly. Yeah. Yeah.
Yeah.
We can
Dinesh,
do that.
maybe if you can in just 5 minutes, just quickly finish the use cases or just 1 or 2 references, and then we switch over to Akash Apurv to carry forward on the security aspect. Thanks, Amit.
Thanks. Thanks.
So thanks, Amit, for this time. So project example, I will specifically talk from the India, and this, what we did is for a data center. Yeah. So this data center was facing some outages. Sorry. So this data center was facing some frequent fluctuation in the power, and identifying a reason for this fluctuation and the source of this fluctuation was a challenge. So we deployed the same solution which I talked about, the Q200 meter, and then the VPN connection, and we put it on a server and access the data. So this service what we provided was for 6 months. And the finding of this service is we found there is some phase reversal was happening in their system, and there was some high impedance fault. So accordingly, the reasons was conveyed to the customer that these are the things, and this both these condition is not impacting their system as such, but will have could have had an impact in future. So we avoided that future impact and find out the source of this fluctuation and accordingly conveyed to the customer for the recommendation. So this is what data analytics and getting into the details of the system will help our customer. One of the example from the paper industries. So similar outages, and we found out root cause. So accordingly, the recommendation was given for decoupling of checking their decoupling scheme. Yeah. So decoupling scheme was checked, recommended, and then they got the problem for their solution, which was various outages in the system. The reason was not known. So this is example for metal, pump industries. So where testing field they were facing unidentified earth faults, so they were not able to find out the reason. And again, the same solution was deployed, and the outcome and what we concluded is there was transience in their system, and because of this switching over voltage, this interruption was happening, and accordingly the root cause was found and then mitigation was given to the customer. So it has again saved their time for these outages. Some example from metal industries in Spain. So their harmonic was a challenge. So continuous measurement was done, and accordingly the solution was given for the mitigation of this harmonic. So in all, the solution what Power Analytics provides you is getting into the details of your system. And when we are talking about data-driven manufacturing processes, the quality of power and the reliability of power is quite important. And this is what power quality analytics services will help you to get that reliable power. And when we are talking about Industry 4.0, so it will help our customer when they are starting their journey for Industry 4.0 to have a reliable and continuous and good power quality. So thanks for the additional time, and that's all from my side. So any question, answer, we are going to address it later.
Amit, you have
We
to
can't hear
unmute
you,
yourself. Amit.
Okay. So I think let me introduce Akasha Purva. So he practices digital enterprise services, Siemens, and he will be taking us through various architecture and solutions for industry security. Then accessing security postures of your manufacturing plant, how Siemens can help to implement and manage secured IoT solutions. So over to Mr. Akash for enlightening audience.
So hello everyone, good afternoon. Now it's good evening, sorry. So is my screen visible?
Yeah.
Okay.
Your screen is visible, Akash. You are not visible.
Yeah, I have
Okay.
kept my video on off mode to save bandwidth. Weather is bad. If we lose it, so it's bad. Yeah. So so good afternoon and good evening to everyone. Industrial security services is what we are going to talk about. When I say industrial security services, then it is actually OT security or operational technology security services which we are speaking about. The tagline is very important, which is in the bottom, which is protecting productivity. And why are we talking about this here? I normally give this example. I like to give this example because this is very relevant, and this is what the today's state is. Yeah. You may be seeing a lot of stats where people are talking about US 400 billion or US 500 billion being the actual spend or actual impact of cyber attacks which have been there on several countries. Yeah. Now in that US 400 billion, yeah, across the globe, if you see, there is a considerable amount of hit which manufacturing sector has taken, and this hit used to be very, very rare. If you look back from 2010 to 2019, the number of incidents which have happened where a cyber attack on the OT environment, that is the manufacturing impact of a cyber attack, has been very less. There have been very less incidents which have been reported, at least. Yeah. So but if you go back and have a look at internet and start to Google, yeah, cyber attacks, etc., you will find that in the last 6 months you have more than 7 major attacks, and these attacks have not been only on one particular location or the other. You just have a look at one of the biggest automobile companies in the world, but attacked reportedly, yeah, at multiple sites, including one in India. There have been reported incidents on a steel manufacturer across the globe, more than 14 units being impacted, and likewise there are many such cases on nuclear facilities or power sector, or be it a pharma, steel, automotive. We are seeing incidents more and more. So it is very important to understand why this is happening, and I will take a moment on this slide again. See, this slide is very relatable to the thing which we discussed in the first session, where people are actually trying, manufacturing organizations are actually trying to move from a non-digital industry on the left side to a more digital industry on the left side, to a more digitalized manufacturing on the right side. Yeah, the difference is now you have a seamless horizontal and a vertical integration, and you ensure that all the related alarms for your processes, so that you can maintain the uptime well, yeah, or you can maintain the quality better, or you have to actually kind of do a process control, yeah, um, uh, streamline your supply chain, right, from ordering from ERP, going to the field for the execution, coming back, what is executed, what is not, optimize that execution of the schedules, yeah, so that you utilize your plant capacity more. What you are trying to do is connect the devices, connect the complete plant, utilize the information on the status of the plant and the assets, and then optimize your productivity. This is very important. This is the way manufacturing IT has been helping up organizations to improve their productivity and efficiency. Yeah, no doubts about it. Secondarily, you may need, this is more of an intra communication within the plant, but say inter-organization communications, where you need to take support from some company to help your assets up and running, to service them, to maintain them, to troubleshoot them. For example, you may need to give access of a plant to somebody else. So this is the inter-company communication as well. So now, see, what has happened is you are opening more and more internet and IT environment to the OT environment. This is there. And even if it was not there, you anyways had a part of an IT, your SCADA systems, your control systems, DCS systems, which are actually anyways having components of IT which are controlling the complete plant. So now with the complete digitalization, what has happened is the information flow within the organization and the data, I'll say the value of the data has gone drastically up. And that's where comes the hacker. That's where the hacker, who was always trying to actually attack financial companies, IT companies, for storing the valuable data on employees, hacking the accounts, etc., they have started to feel we can get into the systems and do something more. For example, few days back there was a story, yeah, when a nuclear facility was being attacked, no damage done, but the malware was inside it. See, reportedly it was seeking information. It was only seeking information, yeah. So just imagine a nuclear facility, if it is not safe, then how can we be very sure? And what can we lose as an organization? What can we lose? We can lose our intellectual property, yeah? For example, our recipes, our production backups, our configurations, etc. We can lose, and we can is an understatement, I'll say. We have been losing many plants. When I say we, let me just express, if I am in India, let me say that I have lost productivity already, because I just give you an example. Few companies have gone to a standstill for few hours to more than one day. Yeah, there could be a sabotage, there could be a manipulation of data, there could be unauthorized use of systems and functions. most of us may be aware what happened in Ukraine when a complete grid was operated. So you see, these are the possibilities which were there, but now these have become realities in today's world, in India and abroad. If not intentional attacks, then there have been mishaps. For example, few companies I personally know who have seen an interruption in the production because the virus and the malware was just sweeping out all the files. In the DCS system, there was nothing remaining. You have to completely redo the installation again, or just imagine your DCS is running and controlling the plant, and you end up into a WannaCry which is encrypting your devices. Yeah. So what you do there, you are actually then having no other option but to actually completely restart afresh, and this is a major loss. So this is the reason people started to take cybersecurity a bit more seriously on the OT environment as well. With all of you as a CIO, I really appreciate Siemens CIOs and the IT heads as well, because we know the amount of care which has been taken on improving the IT security on the IT side has been enormous. Yeah. Now there was no problem there. Problem started to happen when OT environment also started to come in. Yeah, because OT environment offered a different way. It was never designed to be more and more secured. It was always designed to be more and more open, so that you can integrate. Many of you who would be driving a digital transformation topic, the first question you would be asking the partner who is coming into picture is,
Mr. Akash.
because you are
Hello.
creating. Sorry,
Akash, we lost you for a while.
somebody saying something?
Yeah, we lost you for 3-4 seconds.
Okay, am I audible now?
Yes.
Yes, Akash.
Okay, sure. Yeah. So now when the CIOs or the IT heads or the OT heads started to sit together and understand how security can be applied to OT environment as well, the challenge was same IT rules which were there and which were followed very diligently couldn't be applied to industrial security. A reason is very simple. On the IT side, you have a better control. You have you are actually trying to replace the assets of the people. You are trying to force the policies. You are trying to force the applications which can be used, and you are also forcing the patches and the updates for the antivirus systems, etc. However, on the industrial security side of it, you cannot do that. You cannot load the systems with a lot of scanning, because if for that scanning the bandwidth goes down, and if your commands for the control are not happening, that's catastrophic. At the same time, you may not be in a position to patch your systems which are very old. You cannot stop the production just for patching. Yeah, you cannot actually do a lot of antivirus systems for some time because the asset is too old to actually handle the capacity of the virus scan. So there are different challenges. Over and above that, if you see, all of your systems are heterogeneous, and you will not have a single make. For example, you will have multiple instances of industrial control systems from different makes. Yeah, and of course they would have been purchased into different times. They would be running different OS as well. So the complex nature of the industrial OT environment was actually has been very troublesome whenever a CIO has started to think about cybersecurity implementation. And believe me, we have been discussing with many. Probably some of you are already. We have been discussing with some of you already. So I can be very candid about it. And those who have not listened to me, this is very clear. When I have asked the CIOs or the IT heads for the clear architecture to tell them what can be done, etc., sometimes people have struggled to even give that architecture. Yeah, because the amount of transparency which you have on the IT side, if I ask you those details, you'll give immediately. But on the OT side, it has been an organic and a granular growth which was out of control. So what was done? What was done to actually safeguard an OT environment in that scenario? Yeah, people started to think that first let me isolate. First, let me create a network which is completely far off from my IT, because most of the threats come in from the IT environment, and the ones if I stop that road, then my plant would be more or less safe. So the picture on the left side is a fort which is actually
Sorry,
safeguarded by a one.
so we have 5 minutes with us. Then we have to start with the quiz. Thank you.
Okay, so yes, so this is where this picture of fort comes into picture. Yeah, because you see, this is what has been done in many of the cases. You put a firewall in between and actually think that yes, we have safeguarded. Incidents have happened still. Yeah, because you see, protection on the inside of the plant is very difficult to achieve. If you have put a firewall, but if you have USB drives used in your plant systems or your backup systems running, yeah, on which you take the backup of or reports from your systems, in that case you are actually bringing in the vulnerability from the outside, introducing that to the PCs inside. And now these PCs, as you isolated without any big protection mechanism, these are not updated as well. They are having no connection to the internet as well. So that's where the problem started to happen, and that's where we started to say that yes, to achieve a better protection, you need a defense in depth. You don't just go with one single layer of protection, but you do it for multiple layers. Yeah, how do you achieve that? Yeah, and what are these layers? So if you see that fort, I have put into 3 layers, which are plant, network, and system. So you create a lot of security measures on the plant layer itself. On the plant layer, I should be in a position to actually evaluate what's going on in my OT environment. I should also say pad that up with the right policies, processes, and guidelines, so that even if I have some good solutions, my bad processes should not end up into a situation where I expose my vulnerabilities to the outer world, which can be exploited. So now in the middle, we have network security layer, where we have self protections, firewalls, VPNs. We do all those things. Yeah, these things have been very dominant in the IT environment, but these are the things which should be done on the OT environment as well, to ensure that no compromise on the network layer can actually cause a big downtime for me. And on the system integrity side of it, so suppose your network and the plant security has been kind of exploited or has been breached, then on the asset side of it, you should have the right hardening measures. And when I say assets, not just on the PC but the PLCs as well, all of your IoT devices should be hardened enough so that they cannot be compromised. How do you do that? Yeah, how do you do that? So this is a journey. The journey is into 3 major pillars, which is assess, develop, implement, maintain, and confirm. How this starts? Yeah, this starts with the phase 1 of establishing the real requirement. What do you need? Yeah, it is not important to just apply a solution. It is important to understand what do you need as a security measure. What is the business criticality for you? What level of security target, what level should be your security target? Yeah, the second phase would be more towards actually defining those solutions which will help you to say kind of fulfill those security level target which you had considered. And then comes the implementation phase. You implement those solutions which are required. Don't overdo or underdo the protection, because this is a cost. Yeah, and then of course the maintain and the confirm, where you sustain these things. Yeah, you sustain the right policies, the right procedures, and also the right technology. Yeah, so people, process, and technology all have to be implemented for security, at the same time have to be maintained and sustained. Yeah, so how Siemens helps you? Siemens can help you into assessment of OT security. They can help you to implement OT security very well, and they can help you to manage the security and keep it up to date always. Yeah, on assessment side of it, what we have is we do a very detailed assessment on IC 62443 for policies and procedures. How do you manage security? What are you doing there? Yeah, what is your current state? Where can you go? And we also do a very detailed vulnerability scan within your network, so which which devices are already infected, how they can get infected, what are the threat vectors which can act in what situation. So which of your devices are having already many vulnerabilities which can be exploited. Yeah, what are the common vulnerabilities and exposures are there. So this is done at all the different levels of your network, your plant security system, as well as on the asset security system. So this gives you a very clear idea of where are you lagging and where can you do an improvement. So this is how in the end you create a layered architecture where you see that, okay, now I am having major vulnerabilities and tensions and dangers which can be exploited. This is how a hacker or a unintentional virus can act on me. So I should do this. So this is what we come out with. And then once you have that, then your complete architecture can be broken down and any of those solutions can be applied. So if you see, this could be a simple architecture. Yeah, you may have several sections of the plant which are connected to the enterprise network. Then probably to bring in the right data to your IT environment, you may have to have the right firewall rules. You should create right cells and conduits within the system so that there is no wildfire even in case of some attack happens on some section. You should have a demilitarized zone to actually push the patches and the updates and all the internet connectivity. This should go through this buffer. Yeah, you should have a continuous monitoring of the traffic and understand if there are any threats and vulnerabilities already in your system, or some behavioral pattern if the communication between two devices has suddenly gone say out of bound, and you find that this could be a threat signature for a malicious activity. So you should be in that kind of a frame of mind. The infrastructure should come back and tell you that this is my condition, this is how I'm in a position to get compromised, and you have to take some action on that. Yeah, and also the network should be designed in such a way that you have complete segregation between the IT traffic and the OT traffic, and you should be in a position to give. Today, for example, if any company is there, they should be comfortably be able to give this network to an external world to support them. For example, in a case like today, if there is again a virus spread like now, yeah, in that case, you need some support from engineer of Siemens who is not able to reach out to you. You should be in a position to give that VPN secured tunnel based communication to this engineer, and he should be in a position to help you out. So this is what the infrastructure would mean if you have to safeguard your infrastructure. On the right side, there can be n number of solutions, whether it is on the plant side where you have to do a complete kind of a vulnerability detection, deep packet inspection, evaluation of the traffics, or the monitoring of your system, connection of those traffics to the security incident and event management in your security operations center. Yeah, this should be possible.
Excuse me,
So
Akash,
I'll need 2 more
so
minutes, please. Yeah. So let us conclude.
I think we are already overshooting with the 5 minutes, right? So please conclude. I think this is the last slide.
Yeah, so in my watch, I've consumed only 13 minutes. I don't know. So I thought I have 2 more minutes, correct? Okay, yeah. So solutions could be N. Yeah, it could be a demilitarized zone for your networks or hardening of your systems. Siemens can actually support you in all those things, but yes, it is very difficult to actually do that after you really assess what's really required. Yeah. So ending with this slide where I said why Siemens is a right partner. We are one company who has been the front runners in the OT and the automation side. We are one company who are leading the digitalization wave, industry 4.0 wave. We have our own in-house assessors and cybersecurity specialists on IEC 62443. And if you see, we are the knowledge partners of Bureau of Indian Standards on IEC 62443 as well. So this is our credential, and of course we are one team which can deliver end-to-end solutions to you on the cybersecurity. So please feel free whenever you need our support in creating the right cybersecurity infrastructure. So sorry for overshooting if I had. So thanks. Over to you, Amit.
Yeah, thanks, Akash. I think you were actually having deep knowledge, so you were actually explaining everything in detail. So, but we were having some time foundation. Sorry for that. So,
No
I
issues.
think, yeah. Thanks for that enlightenment of audience, right? So, with this, we are entering last leg of our webinar. Okay, and so we are back with some more interactive Q&A session, followed by a quiz where again the participants, the top 3 participants will get Amazon vouchers. So please stick to your Q&A session. After that, wait for the quiz to start. So I will be asking questions which I think attendees have given that. So I think speakers, please pick the questions. I will be calling on with the various questions which attendees are sending. Okay, so Sunil Gurbani is asking, what are the major challenges in COVID-19 environment? So Nitin, Apurva, or Dinesh, you can pick it up for.
Yeah, I think
I,
there are certain challenges in the COVID-19 environment. First of all, is cybersecurity. There have been several cyber attacks in the COVID-19 environment in the last few months. There is a challenge of on the shop floor, the trained manpower has got vanished. So how do you run production with the new manpower? How do you skill them on the job? This is a challenge. Yeah. Then there is a challenge of how my quality does not get affected when I'm working with completely new manpower. So there are completely new challenges which have come up in this COVID-19 situation. Also, how do I maintain a social distancing on the shop floor? So several challenges have come up.
okay, so with this, we are picking the another question from Mr. H.S. Ravindra. Proper RCA is really important. Well appreciate in this case. What kind of RCA programs do you adopt in this plant? I think this is
I
the
think
plant
this is
which
a
you have been
question very
very
specific to the case study. So, Sushil, why don't you take
yeah,
this?
that is.
So let me first reiterate the question. It was related to the root cause analysis. Am I right?
Yeah, RCA is really important. Well appreciate in this case. What kind of RCAs do you adopt in this plant? I think Siemens plant he is trying to ask.
Yes. Thank you. So, see, when we talk of root cause analysis, it is from two perspectives. One is, so, okay, in a more simplified manner, it is from a process perspective and a quality perspective, rather product perspective. So, when we talk of root cause analysis, see, when we have traceability as a part of my digitalization initiatives, basically we have complete insight about the manufacturing process, that when the product was produced, how it was produced, and therefore when we want to do the root cause analysis, this entire data gives us a lot of insight, and this becomes very much handy when I'm doing the RCA. So I hope I could answer the question.
Yeah, I think that was I think elaborative. So there is another question which this is the last one, I think. Power analysis. Share more about data lake presentation layer, maybe in a separate mail. Okay, there we can have a separate mail also. Keen to know proactive identification. How quickly it is rectified. It only detects or fixes the issue if possible. So power analysis question. I think Dinesh, some more about data lake they are asking. This is Milind Kutarni.
Yeah, so various data layers, as I explained in my presentation, the clustering is done. So once we get that data, so we do that clustering and then categorize that data, and then based on the details of data, and this data is also clustered based on artificial intelligence and machine learning. So I will get the data only which is abnormal. So whatever normal situation operating system is there, so that data will not come for analysis, and that data will analyze and accordingly will submit the result. So what additional details user want, or we can send them in a separate mail if details we have.
I think with this, like, I think this was the last question. So we move on to our quiz section. I hope all attendees have their Kahoot ready. So we can start the quiz now. So guys, pin number 371503. It's on your screen. 371503. Great. BP again. Yeah. SKG, Ajit. Many guys. Ramanath. Ramanath, you have forgot to mention the mobile number. Upkar yet again. AK. Siva. Yes, Ravi. Manish Mathur, you forgot to put the mobile number. JP. RN. PJ. Great. Kapil. Ram. Sushil. Yeah. We are still waiting. Pin number is 371503. Sushil, you forgot mobile number. Ashok. JP. Kapil. Okay. TS. A few more seconds. 371503 is the pin number. I hope everybody will be ready by now. Yeah, we can start now. What is the global standard for security of industrial control system ICS networks? So options in front of you: ISO 27001, IEC 62443, IEC 61850, ISO 17799. 3 seconds. 2, 1. Yes. So correct answer is IEC 62443. 13 correct answers. SA is topping with 937 points. BP second, Ravi third. So I think PG and JP are just behind them. How can OT threats affect your business? 4 options: loss of intellectual property, production recipes, etc., plant standstill due to virus or malware, unauthorized use of system function, all of the above. Yes. Time over. 27 correct answers. Great. So only one wrong. SA is leading. PG has taken up the race. PG second, PP third, Ravi and JP are following. Come on for the next question. How is OT security different from IT security? High availability demand from OT. OT security is risk-based approach. OT security demands understanding OT protocols and software, or all of the above. 7 seconds. Yes, 3 seconds. Yes, most of the guys are correct, all of the above. PG is number 1 now. BP second, Upkarji third, SA, JP are following up. When should a manufacturing company consider cybersecurity? Automation design and planning, operating on maintaining a factory, both or none? Six seconds. Time over. 28 answers, both is the answer. So PG is leading, BP second. JP has a streak with 4 correct answers in a row. JP, you can catch it. Which of the following attacks targeted OT environment? In Destroyer, Snake ransomware, Black Energy, or all of the above? "28 correct answers. All of the above is the answer. So now the results. 5 out of 5. Upkar. Third. BP second. And first is PG. Great. Congratulations to all the winners. Runners up are SA and JP. Well tried. So winners will get the Amazon vouchers. So I think with this, we conclude with this webinar, and I hope all the audience have got the great knowledge sessions from all the 3 speakers. And I thank from on behalf of CIO Club all the attendees who have joined, and all the best wishes to the winners, and enjoy the coupons. And yes, don't forget to register CIO Club. You can go to the URL and register there. So I wish everybody safe and prosperous day ahead. Thank you.
Thank you.
Thanks a lot.
Thank you, everybody. Thank you, Akash. Yeah,
Thank you.
Thank you. All the
Thank you.